Hi, good evening, everybody. This is Christian, and it's good to be with you. Thanks for following along. This will be a quick video on solving exponential and logarithmic functions to continue with what we've been talking about in class. So goals for the video here, we're going to revisit exponential and logarithmic functions just to remember what they look like, revisit some log rules, and then we'll solve both types, like an equation with exponential things in it and an equation with log things in it. So just to revisit some rules we've looked at, we know if we have some value a times log b, then that works out to be the same as, so that coefficient in front becomes the input on the, or the exponent on the input on the log. So let me say that again. The coefficient on the front, the a, becomes the exponent up here on the input of the logarithm. So a log b becomes log b raised to the power a. If we have log of a quotient, then that's the same as the log of the numerator minus the log of the denominator. Similar with, those are my cats running around and picking on each other. So log of a times b, that's log of a plus log of b. If we have y equals log base b of x, what that's asking, that's saying y is the power that we raise b to get x. So we'd have b to the y is equal to x. And then log base b of b, that's equal to 1, again, because 1 would be the exponent that we raise b2 to get a b. So let's look at an example. We'll do some together, and then I'll have you do some on your own. So let's say we want to solve 6 equals e to the 2 root x. Now, the thing we're looking for is x, so we want to do some things and then say x equals some stuff. And we want to then bring x down out of the exponent, and the only way we're going to do that is through log rules. So specifically that rule, the first one we mentioned, if we have an exponent as the exponent on the input of a log, then that exponent can come to the front and be the coefficient. So we could introduce a log to this equation and it would bring the exponent out front. So let's rewrite our equation. Here's equals, here's the 6, and here's the e to the 2 root x. Now let's apply the natural log, or take the natural log of both sides. And now that we've introduced the natural log, these log rules apply. So on the left side, we'd have natural log of 6 still. Oop, meant to switch colors. There we go, 6 equals. Now on the right side, let's take this thing. Let's copy it. Let's put it right below. There we go. But let's scoot it over a little bit, because we're going to grab the exponent and put it in front, because that's the log rule. It now becomes the coefficient rather than the exponent on the input. Okay, now let's keep going. Now we have x in like the base level, and we can do other things like divide by things, multiply things on both sides, whatever. We still want to get the x. So what do we have? This natural log of e, the current base is an e, so that reduces to 1. That's the log rule right here. Log base b of b is equal to 1. So here we have log base e of e, that's equal to 1. And so on the left side, we would have natural log of 6 is equal to 2 root x, and then all of this piece became a 1, and we're multiplying. So it's 2 root x times 1. Now let's to get x by itself, let's undo the multiplication of the 2. So we're going to divide by 2 and then deal with the root. So if we divide by the 2 on both sides, then on the right side, these 2's cancel away. They reduce. We're left with root of x. And then on the left, we have natural log of 6 divided by 2. So natural log, hi Blaze, natural log of 6 divided by 2. Now, what do you need? Just to mention this, we have natural log of 6, that's a value over 2. This, we cannot divide the 2 into the 6 and make it natural log 3. It does not work this way. Currently, this is no different than 1/2 natural log of 6, which with our log rules, incidentally, just to say, 1/2 natural log of 6, that first rule says the coefficient can become the exponent on the input. So this is the same as natural log of 6 to the 1/2 or natural log of root 6. It would not be natural log 3. Okay, then the last thing to do is to get x by itself. To do that, let's square both sides of the equation. So the right side becomes x, the left side, that exponent applies to the 1/2 and it applies to the natural log 6. So we end up with 1/2. Actually, you know what? I'm going to put that 2. I'm going to put that 2 back in the denominator like this. And now I guess I want to say that the exponent applies to the numerator and it applies to the denominator. It squares both things. So we would have natural log squared of 6 over 4. That's what our x is going to equal. Okay, now I want you to pause the video and work through this next one. Try to get the x out of the exponent by applying a natural log to both sides and see what you get. Okay, let's pause. Okay, so maybe you did something like this. You have the 7x equals 21 to bring the x down front and make it base level with the 7. You need to apply some sort of a log of any base to the equation. Here I chose natural log. So if you choose natural log, then x moves to the front. That would give you natural log 7 equals natural log 21. Then to get x by itself, you divide by the value natural log 7 on both sides. That gives you x is natural log 21 divided by natural log 7. And that's the best you can do. You cannot reduce the 7 into the 21. This is not natural log of 21/7. All right, that's one way. Another way would be to change your choice of log you use to apply to the equation. So if we have here, let's just use orange. Well, no, I'll use same colors. Let's use 7 to the x equals 21. Now let's take, since the base is 7, let's use log base 7. So log base 7 of 7 to the x. And let's move the 21 a little further over and take log base 7 of the right side. Then the left side, the x still comes out front. You'd have x times, that's an x times, then log base 7 log base 7 of 7 equals log base 7 of 21. Now, let's look. What is this equal to? Log base 7 of 7. That's asking, what is the power you raise 7 to get 7? And it's 1. So all of that reduces to 1. We're just left with x on the left-hand side. And log base 7 of 21 is our answer. And I know they don't look the same, but these are the same value. They're the same value through x is the same numerical value, even though they don't look the same, through the change of base formula. Change of base formula telling you, let's rewrite x as something like this, where we get to choose our logarithm we're going to apply. So we get to choose some new logarithm. Let's choose natural log of the top, natural log of the denominator, or natural log of that 21 divided by natural log of 7. We've changed the base from 7 to the base e and written it as natural log e of 21 over natural log e of 7, the same thing that you see on the left-hand side. All right, we're going to pause there and stop the video. We're going to, I'll make a second video. I don't want to make videos that are too long because they take, I don't know, they can take a little while to digest. So that's a video for now. Again, we looked at logarithmic exponential equations. We have logarithmic functions next. That'll be our next video. Here we revisit log rules, and we started solving those equations. So we solved two exponential equations. The next equations that we would solve are these two here, using some more log rules and some more math, tricks or legal math rules that help us solve those equations. So thanks for being here. Please reach out with any questions. You can send me an email, message me on Teams, and stay tuned for video number 2. Thanks.